This is a concept that I think is quite basic, but I think it will help a lot of students in the run-up to their senior maths challenge exam. So what I'll be doing today is I'll be going through the numbers from 1 to 10, basically to see how we can test how each of these numbers are a factor of any integer. So to start off with, number 1 is very basic. Every integer is divisible by 1. So for the number 2, every number is even. That's a way we can test the number 2 as a factor of any integer. If that number is even, it must be a factor of 2. So every number which is even must be a factor of 2. The number 3, now there's quite a unique test you can do here. What you can do is, if you take the digits of any number and add them up, and the sum of that result is a multiple of 3, then it must have a factor of 3. So I'll give you an example. Let's say the number 27, which we know has a factor of 3. If we add 2 and 7, we get 9. And of course 9 is a multiple of 3. Therefore, 3 is a factor of 9. Therefore, 3 must also be a factor of 27. So if the sum of the digits add up to a multiple of 3, the number must have a factor of 3. Okay, now the test for the number 4 just follows on from the definition of testing a factor of 2, which is if the number is even and it's divided by 2 and that number is also even, it must be divisible by 4. So if when halved the answer is even, the integer as a factor of 4. Basic example, let's say number 24 divided by 2, you get 12. Divide that number by 2, you get 6. 6 times 4 is therefore 24. Therefore, 6 and 4 are your factors of 24. Number 5, everyone has learnt this growing up. Any number that ends in a 5 or 0 has a factor of 5. Now the number 6, in order to test whether 6 is a factor of any given integer, we need to apply concepts 2 and 3. So now concept 2 is if your integer is even, it has a factor of 2, and concept 3 is if the sum of the digits of the whole integer add up to a multiple of 3, it must be a factor of 3. Therefore, if we apply both of these concepts, the integer will have a factor of 6. Now, the number 7 doesn't have a distinct way of determining whether an integer is a factor. But what we can do is, like any other number, is we can test whether that number divides into another number. And if there is no remainder, then we can say that the number 7 is a factor of that integer. If the number 7 is divisible by an integer where it has no remainders, 7 is therefore a factor of that number. Okay, so number 8. We apply concepts 2 and concepts 4. When an integer is halved, and halved again, and the answer is even, it has a factor of 8. Okay, so if we take an example, let's use 16, basic example. So 16 is obviously an even number. If we halve that number, we get 8. And if we halve that number again, we get 4. 4 is even, therefore it must be a factor of 8. Because what's happened is we've halved it, so we've divided it by 2, halved it again, so we've also divided by 2, and it's even, which means we can divide it by 2 again, which means that the factors of this number is 2 times 2 times 2. Now number 9 has a very similar set of rules to determining the factors of 3 and 6. Add up all the digits of the integer and test whether it has a factor of 9. So if we use our example 27 again, so we've got 27, add those digits, is 2 and 7, which is 9, and 9 is obviously a factor of 9, 9 and 1 are the two factors that make up that multiple of 9. So yeah, that is the test for 9, and the test for 10, nice and easy, is if it's a number that ends in 0, then it must be a factor of 10. Now what may happen in the UKMT Senior Maths Challenge is you may be given a set of large integers in which you need to test whether they are prime. And these set of rules are the perfect way to do that, because the good thing about them is they're very quick and they're very easy to get your head around.